recording it doesn't mean you can't interrupt and talk and stuff, but it just means that this part of the lesson is going to be videoed, and then you'll know about it later on. So reactivity is related to all of this. See, sodium and lithium are quite reactive because what all atoms like to have is a full outer shell. Now, it's really easy to give sodium a full outer shell. I just need to remove one electron. And it's also really easy to make lithium a full outer shell. I just need to remove one electron. So they're both very reactive. Now, it's actually, sodium is more reactive than lithium. So that's a bit of a harder question to understand. If we go to the periodic table over here, remember to follow me. You just click on my circle. And then you'd have to keep on zooming in and so on. If you just click on my circle at the top right. So group 1, we see, I said sodium was more reactive than lithium. Well, guess what? Potassium is even more reactive. Rubidium is even more reactive than that. And it goes down. So francium is actually the most reactive metal on the entire periodic table. There's nothing more reactive. There's no more reactive metal than francium on the periodic table. That's fine, but that doesn't really fully explain it. We understand it because we understand why all of these are reactive, because they've only got to lose one electron. But why is francium more reactive than cesium, and so on and so forth? Well, I'll come back to that in a moment. The other reactive elements are these ones here. Now, fluorine, these are the halogens. Group 7 is the halogens, and they have 7 electrons in the outside shell, right? Because it's group 7, yeah? So all of them are going to be very reactive. So why are all the halogens going to be very, very reactive? Yes, so it's related to the amount of electrons in the outer shell. Now, remember, all atoms want to have a full outer shell, right? Now, the group 1 metals, they were very reactive because they only needed to lose one electron. These are very reactive because they only need to gain one electron, okay? So actually, it turns out that all metals prefer to lose electrons, and all non-metals prefer to gain electrons when they're reacting. And the reason for that is, when you think about it, not too hard to understand. We know that all atoms are trying to make a full outer shell, and metals have a nearly empty shell, a nearly empty outer shell. So it's a lot easier for them just to lose electrons than to gain 7 electrons. I mean, that would be crazy. Might as well just lose 1 electron instead of gaining 7, right? Whereas something like a non-metal, like one of these halogens over here, they've got a huge amount of electrons in the outer shell. They just need it topped up. They don't want to empty that shell. They just want to top it up and make that one a full outer shell. So non-metals prefer to gain electrons, and then metals prefer to lose electrons to make a full outer shell. That's when they're reacting. Now, we can look at bonding and reacting in another video, but we want to just look at reactivity now. So group 7, very reactive. They only need to gain 1 electron. Group 1, very reactive. They only need to lose 1 electron. But why is lithium less reactive than francium? And it just so happens, actually, it's the other way around with the group 7. This is the most reactive metal. Sorry, this is the most reactive non-metal. This is the least reactive halogen. Okay, so why? It's a bit weird, isn't it? So the reason why, if we look at a picture of lithium. Look at a picture of lithium over here. Although it's only 1 electron, I still have to remove that 1 electron, and it's being pulled towards these protons. These protons are positive, so they're going to be attracting this electron. Yeah. So when I'm pulling it away, the protons are going to be trying to pull it and saying you can't have it, and I'm trying to have to fight the protons, right? If I go to sodium, exactly the same thing. The protons are still attracting that electron, but now the electron is further away. So the protons don't have as much of a hold on it. So the protons are still pulling, but not as much as they were before, not as much as they are in lithium. I still have to remove only 1 electron, but I don't have to fight so hard to remove it. So if you imagine as you go down the periodic table, those outside electrons are going to get further and further and further away from the nucleus in the middle. The nucleus, which is positive because the protons are attracting that outer electron, and I'm going to have to push harder and harder and harder to try and get it away. But when it gets down to francium, they're not holding it quite so tightly. Yeah? Okay, happy with that?
Yeah.
Okay. So what about the opposite here? With these guys, fluorine's the most reactive, and this is the least reactive of that group. But remember, this time I'm trying to give it an electron. So now we want the nucleus to be close, because we want to say, here, take it. I'm not fighting you anymore. I'm giving you something. And so the nucleus is positive. So I get a proton and I want to put it there, and the nucleus is like, yep, come on then. And it's just going to collect it because it's got that positive charge. It's nearby. So now we want a small atom, and so that's why this is the most reactive non-metal, and this is the least reactive. Sorry, and this is the most reactive metal. Okay, so I'm going to stop that video there.